So I'm fairly sure we will see this with the numbers of succeeding people. It's difficult, more difficult than last year.
Good morning, everybody. Welcome to Advent of Code Day 5. My guest today is Frank. Good morning, Frank.
Hello, Thomas. Nice to be here.
Yeah, you're welcome. Frank, can you explain us the riddle for today?
Yeah, today I will try to explain. So here in today's riddle, we have to do with mappings. So in this text, we get an initial list of numbers, and then we have to map this list of numbers to a new list of numbers where each single number is mapped by a special rule. And these rules are described in this input file. So each such a line with a double dot in the end is the start of a mapping section. And here we got a range. This 50, 89, 2 means, in example, that the range of numbers starting at 89 of length 2 is mapped to the range of numbers of 50 of length 2. So the 89 is mapped to 50, 99 is mapped to 51. And so also the same applies to this mapping. And so if we apply these mappings to this list of numbers, then we obviously get a new number. And then in the end, we want to find from this list the minimum entry. And then there is one special rule in it, which says if such a number is not matched by any of these rules, then it's an identity mapping. So it's the 79 would then be mapped to the 79 itself.
Also, for example, if we're starting with 79, we go to the first map. 79 is in the second row.
Yeah, exactly.
Yeah, and then it becomes 81.
Because this range starts at 50 and this at 52, so it's mapped two steps up like this. So 79 plus 2 is 81.
And then we use 81 for the next map. In the next map, it looks like in the middle, that the middle one is used.
Then you have to calculate.
No?
No, 52 plus 2 is 54. So this 81 is not in the mapping of 52 to 54.
Then there is no mapper, then it's the same. If there's no
mapper, it's the same, exactly.
Then it's the same.
So down there we have an example. Let's see it. Here it is. So the 79 in the first thing, it's mapped to 81, and then it stays 81, and again stays 81, and then in the fourth mapping, it's mapped to 74. We could now see in the fourth mapping, I guess it's here. Yeah, there, 25, 70. There's the 81 inside this thing because it goes from 25 to 95, and then it's mapped 7 down, so it's -7, and
74.
This is 81 minus 7 is 74. So this is how the mapping works. So we end up after applying all these mappings with a list of 4 numbers, and from these 4 numbers we take the minimum one, and this is the solution for the star one. And this sounds not too complicated, but on the other hand, it sounds like an implementation nightmare. And if we try to implement it, it feels like an implementation nightmare because it's difficult to parse here, of course, and then applying these mappings and keeping track of mapped and unmapped numbers makes it a bit complicated. So I give a quick overview of the code. So I got a list here A. This is always my list before applying the mapping, and then I got a list B, which is the list after applying these mappings, and then I do this in step, and for each map after the mapping applied, I make A equals B. So copy the B to the A. And then I end up with A in the end, having the right numbers.
What we see is Rust code,
Yeah,
right?
this is Rust code, fairly procedural. Again, I try to make it more object orientated or more structured, but I didn't succeed with this today. But well, even the unstructured code works for the first star more or less well.
Okay, then leave the code. Can you explain us the second part of the riddle?
Okay, and in the second part of the riddle, the meaning of the input changes somehow. Then it's not that we got 4 numbers here, but instead we got 2 ranges. And the first range is this range starting at 79 with a length of 14, and the second range is starting at 55 with a length of 13. And this looks harmless in first place, but in the real input data, this is only the example, in the real input data, this is big numbers. So actually, if we would simply flatten this list of numbers or this list of ranges into a list of numbers, then we would have a list of like 2 billion numbers, and then everything needs a lot of memory and runs like forever. So we need to implement this in a more clever way. So instead of working with simple numbers, we now have to work with ranges, and this makes it a bit complicated because such a range as such a mapping is in range, and we got in range, and we need to consider several cases.
Okay,
yeah.
To summarize, in the first riddle we got 4 seeds to check, and now in the second riddle there are 2 ranges from 79 to 14 ranges, and then from 55 13 ranges. So we got 2 ranges we have to check, and in the real riddle there are a lot of digits to check, which is impossible.
Yeah, it's impossible to make a simple list of it, so we have to work with ranges, and this work with ranges makes it pretty complicated. So I worked like 2 hours on the second star and didn't succeed in making the code really working. So it's half ready, half not working, and yeah, it's complicated rules here. So it's an implementation problem basically.
Okay.
But I'm fairly happy to have got the first star, and so
Yeah.
I can go to work now.
But congratulations. What is your rank for the first star?
At about 8,000.
8,000.
So, yeah.
Okay. Then some other comments?
Actually, this is a nice riddle here because it's not so simple. I didn't expect this on the 5th day. So compared to the last year's riddles, it's a very difficult one. So I'm fairly sure we will see this with the numbers of succeeding people. It's difficult, more difficult than last year.
Okay. Then big thank you, and yeah, have luck to solve it.
Yeah, thank you, and we see you tomorrow.
Yo, bye-bye.
Bye.